Welcome to the video, and now like we are going to start our discussion. As our first question, we are going to discuss about what is data mining? Okay, I think this is the first video. This is the first video from my side, and we're going to watch this video. Please watch this video till the end. And coming to the notes, what are the topics I'm discussing in this video will be present in the description section in form of a PDF. I will be uploading to the Google Drive, and the particular Google Drive link will be shared in the bottom where the PDF was uploaded. So please refer the description for downloading this PDF discussed in the video. Okay, so without any delay, let me start this. Let me start answering this question. And what is the first question is what is data mining? So answer, data mining refers to extraction or mining mining knowledge from large amounts of data. Large amounts of data, and data mining is essential for is essential step in knowledge discovery process. And next, the interesting patterns, the interesting patterns can be presented to the user presented to the user presented to the user and maybe let me add a new page. Maybe stored as a new knowledge in the knowledge base. The data mining step. The data mining step is the crucial is like data step. Data mining step is interact is the interacting is may interact with the user. The data mining step may interact with the user. Let me erase this. The data mining step may interact with the user and knowledge base. The data mining is only one is only one is the only one step, an essential cause, essential because data mining uncovers hidden patterns for evaluation. As our second question, we are going to discuss about what is normalization. Answer: normalization, where the attribute data, where the attribute data, where the attribute data or scaled as for within a small range, within a small specified range, a small range, small specified range, Z score, normalization, or zero mean normalization of an attribute A. The value A, V of A is V of A is normalized by like V of V of A is normalized to V dash by by calculating by calculating A and SA, or mean and standard deviation. Let me add a new page. Standard deviation. Standard deviation respectively of attribute A. Attribute A. This method of this method of normalization is useful when actual minimum and maximum of attribute A is unknown. Or 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 when there are outliers outliers that dominates min max min max normalization. V dash is equals to B minus A dash by sigma A. And that is, let me give an example for this. 68,000 minus 3,000 38,400 divided by 12,300. Okay, when you calculate this, you're going to get 2.3068, which is approximately 2.31, 2 point, okay, which is 2.4068, approximately 2.41. Let me add a new page. Now, our third question is, write the difference between classification and prediction. So it will be going to be more interesting. So like classification and prediction. Let us see the difference between classification and prediction. Classification. Left hand side will be classification and right hand side will be prediction. Constructs a set of models or functions to describe or distinguish. So what we are going to distinguish? We are going to distinguish the data values, data classes, or concepts. And coming to prediction, builds a model to predict the missing numerical data values. Okay, missing and unavailable numerical data values. Let me add a new page. Coming to classification, used for predicting class labels, for data objects. Use it like coming to prediction, use it for predicting missing numerical data values. Now as a fourth question, we are going to see the difference. Write the difference. Write the difference between agglomerative agglomerative clustering and divisive clustering. Agglomerative clustering, divisive clustering. It is a bottom down approach. And here it is a top down approach. It made a new page. Compare the difference. And coming to here, second difference starts with each object. Starts with each object forming a separate group. It successively merges the objects into successfully merges objects that are into a group that are close to one another. Until all of the until all objects are merged into one. Or until a termination condition holds. holds. Now let us see the now let us see the second point in divisive clustering. Starts starts with the objects starts with the all objects in the same cluster in each iteration. In each iteration, a cluster splits into smaller clusters until until eventually each object until each object until each object forms its own cluster, or until a termination condition holds.